Hey Skywatchers, I am now beginning the year of pure exploration, well mostly pure exploration, of the NGC catalog compiled by J.L.E. Dreyer back in the 1880s based on many submitted reports to some degree validated by his own observations. It began with the Herschel list. I believe that had 500 to 1,000 studies in it that William Herschel and his dad and the family had basically discovered over time in the 1860s. Dreyer himself had been involved with a variety of observatories, and I believe mostly in the UK at the time. What we're seeing here is the field of view of a planetary nebula, NGC 6309 in Ophiuchus. The nebula is 11.6 magnitude, 20 by 10 arc seconds. So it's pretty small, 8,900 light years distant, and its central star is magnitude 16.3. It's not in the sky's middle third, but we are getting a nice field of view. And the best way to make out planetary nebulae is to watch them grow on the screen. However, I started the actual recording of the screen a little late, because typically stars will jump out fairly quickly and the nebula tend to grow more slowly over time. So I'm not sure if the nebula is actually on the field, where it is on the field, but it should be on the field. The go-to alignment's pretty accurate this evening. So there's our look, a nice stellar field, and that somewhere on it is Planetary Nebula 6309 in Ophiuchus. Well, to be clear, there's probably no way we saw exactly anything in the field of view that I've already observed, because Messier 13 was quite a ways off. In fact, the core was right over here on the left side of the screen, which means neither the planetary nebula or the galaxy would have been found on it. So it does appear as though the go-to alignment is a little fouled up, and I'll have to spend some time on it tomorrow straightening it all out again. Anyway, this is Messier 13. We'll use it just to get a look, get it aligned, and I'll go back to NGC 6313 to see if we can get it centered on the field. After all, it was a rather brightish galaxy at magnitude 12.9. Well, it's July 7th, Thursday, about 10:45. Clearly sky dark, although there's evidence of atmospheric humidity up there. Lights reflecting from the town of John Day. I'm beginning my expeditionary tour of NGCs at 6400. What we have here on the screen is a deep south open cluster in Scorpius. 6400 is magnitude 8.8, about 12 arc minutes in size, consists of about 60 stars. The brightest are magnitude 9. It is a double I2 class, which I'll have to look up tomorrow, 3,100 light years distant. It is at minus 37 degrees almost, and I believe that's the cluster. I had to redo both the mechanical and the digital alignment on the mount because I was not getting consistent results on GO2 if I move more than 5 or 10 degrees at a time. But this is after doing mechanical alignment on Antares, Deneb, and Ras Algethie. And as it turns out, after swinging all the way from Altair to lower Scorpius, which is a distance of about 45 degrees, if this is our cluster, it looks pretty good. Let's go on to a next NGC study that will be in range. Okay, this will be the acid test. This is a globular cluster in Ophiuchus, 6401. I believe I've imaged it previously. Very tiny. I'm going to get the data on it, but it's clearly right here. So it's centered up pretty decently, although I might want to do a slight synchronization on it before leaving, especially if I start seeing things jumping around. One of the things I want to point out immediately is how beautiful the stellar field is there. You can actually see some obscuration nebula. This would Perhaps Barnard, who was into obscuration, dark obscuration nebula, gave it a designation. But we're just going to stay with this for the time being. NGC 6401, I'll give you the data on it. As I said, I have imaged it previously. I am very happy to see it turn up in the field of view in a pretty righteous position within, let's say, about 3 or 4 arc minutes of the center. NGC 6401 is a globular cluster in Ophiuchus, brightish, magnitude 7.4, but extremely small, 1 arc minute, 24,000 light years distant. This is a very tiny cluster. It's a class 9, which means it's fairly diffuse, all you can see the core there. But at 24,000 light years, it's almost as far, about the same distance as Messier 13, which is magnitude 5.8 or so, and is some 20 arc minutes in size. And this is a class 9, so it isn't a very condensed cluster. The data may be off on this, but that field of view is spectacular. What you should see forming on the screen right now is NGC 6404. It's an open cluster in Scorpius. I'll give you the data on it in a second as it formulates on the screen. You can see the cluster is quite apparent there. Clearly different as open clusters than globulars. 6404 in Scorpius, open cluster, magnitude 10.6, some 5 arc minutes in size, 50 stars. It's a class 3-3, 7,800 light years distant. And you can see the cluster right there. It's pretty obviously an open. In open clusters, you never see a condensation towards the core. You might see some brighter stars towards the core, but there's really no sense of luminous nebulosity there. So good. So far the tracking's quite good, and that ended up pretty close to where the globular cluster was. Here we're going to go to another open cluster, 6405 in Scorpius. This one's minus 32 degrees. The scope should tip a little bit. Did not move much. How about that? Very open cluster. Let me reinitialize the camera on this one. NGC 6405, very open cluster with very bright stars, large. This is also known, by the way, as Messier 6. Magnitude 4.2, 20 arc minutes in size, 80 stars. The brightest are magnitude 6.2. It's a class 3-2. So we're getting some hints about the different classes. 1,600 light years distant. Nice to have seen Messier 6, as also known as NGC 6405. Okay, this should be a good test of alignment. NGC 6408, some 40 to 50 degrees, almost due north of Messier 6, the open cluster with 6407. I'll give you some data on it. We should expect to see the galaxy close to the center of the screen. It's quite apparent. It's got a bright circular stellar core with a large aura. Basically, it looks like a face-on spiral galaxy. I'll give you the data as I search through it. I believe it was 6408. We'll confirm that. Wow, some of the mechanical adjustments I made again to the mount, plus realigning to stars, turned out quite nice. This is 6408. I'm going to see if it's going to move. Anyway, if it's 6408, it's a galaxy in Hercules, magnitude 12.7, 1.6 by 1.4 arc minutes, a spiral with a bar, 181 million light years distance. And one thing we can be aware of is it does appear to be rather face-on, 1.6 by 1.4 arc minutes. I'm going to pop to it just in case I got it wrong. Nope, don't think it's moved at all. So we're going to move on to the next 6400 series NGC in a moment here. I'll let you evaluate this study, NGC 6415, as I gather data on it. Notice it takes about 20 seconds or so at 128 flood before the image starts to come together reasonably well. 6 passes, probably a second and a half each, but I've also, actually probably around 2 seconds each, but there's also image stabilization, which takes quite a while. NGC 6415 is an open cluster in Scorpius. For some reason, it's also calling it M12, which is not the case. Minus 35 degrees. If there's a cluster there, it's hard to tell. However, there are stars all over the screen. I am not seeing anything that I would describe as a cluster. So let's move on, but it is an interesting star field, isn't it? I'd say stars ranging from about magnitude 13 here, and the very faintest are probably around magnitude 16. Have a look at this one as it forms on the screen, NGC 6416. Also in Scorpius. Well, clearly an open cluster right around in here. Stars ranging from probably around magnitude 12 and fainter. But this says the brightest star, ooh, interesting. There must be lots of atmospherics tonight because it says the brightest star in NGC 6416, the open cluster in Scorpius. The cluster itself is magnitude 5.7, 14 arc minutes in size, so it should go all the way across the screen when centered. There are 40 stars and the brightest is 8.4, which I kind of find a little difficult to believe, except for the fact there's some luminosity in the atmosphere. The scope's at full tilt. So that brightest star would be, of course, this one right here. Not a lot of stars, 40, 2,400 light years distance. It's a class 1V1. And let's see what was next on our adventitious study list. Okay, let's watch this one emerge. Like planetary nebula, galaxies slowly emerge, making it much easier to distinguish them. This one looks like it's pretty much right in the center of the screen anyway. This is NGC 6417. I'll give you some information on it. Looks kind of smallish. My eye, maybe magnitude 13, maybe 1 by 1 arc minute or so. What the data is saying here on NGC 6417, Galaxy Hercules, magnitude 13.1, 1.4 by 1.3, spiral with a bar, 152 million light years distant, probably smaller than our own, or about the size of the Milky Way. 23 degrees north, so it falls in the sky's middle third and should give a decent view. Okay, we'll let this one assemble on the screen as I look it up. This is NGC 6421. If you're not seeing something on the screen, there's a reason why. Boy, there's an awful lot of spread of bright stars up there. This, however, is NGC 6421, an open cluster in Scorpius. Magnitude 14, a mere 1 arc minute in size. So somewhere amidst all those bright stars is a 1 minute arc second sized magnitude 14 open cluster, 4,900 light years distant, pretty deep south at minus 33 degrees. Frankly, I'd be looking for something to slowly emerge. A magnitude 14 open cluster would be as faint. I have yet to actually note having tracked one down. Most are in the 7 to 10 magnitude range. So this baby ought to be a challenge, but what an interesting field of stars. So I'm hoping that while the screen was assembling, something faint started to emerge somewhere in this region of the screen, since the tracking's been pretty good, or the go-to has been pretty good. Galaxy in Draco, lots of galaxies in Draco. Here's another open cluster in Scorpius. We'll go to it. I'm going to bail on the camera first, however. NGC 6425, open cluster in Scorpius, magnitude 7.2, 10 arc minutes in size, a mere 35 stars, the brightest are magnitude 10.1. It's a class 1-1, 2,500 light years distance, minus 31.5 degrees in terms of its declination. And given that data, pretty clear that open clusters in here somewhere. There may also be some star-forming material right at that location associated with it, or somewhere blocked in between it and the cluster, which I said is 2,500 light years distant. So here we go, NGC 6426. Have a look at it as it forms on the screen. I'll give you the data. See if you can figure out what it might be. Hopefully it'll be somewhere on the screen. We've had pretty consistent results so far. NGC 6426 is a globular cluster in Ophiuchus. Faintish, magnitude 10.9, smallish 3.2 arc minutes. The brightest stars are magnitude 15.2. It's a class 9, which pretty much puts it in the Messier 4 kind of class, so it's fairly diffuse, 65,000 light years distant. And basically, if it were 6,500 light years distant, it would be 32 arc minutes in size, the size of the moon. So it is roughly the same size as M4, which is about 75 light years in diameter. Nice to see another faint globular cluster. I'd like to pick up one in the Palomar class around magnitude 12 later on, we'll see. Okay, let's follow the generation of this image. It's NGC 6427. See if you can work out what this one is. It's in Hercules, which is suggestive, because we know there are quite a few galaxies in the Heroes constellation. This is NGC 6427, a galaxy in Hercules, of course. It's also known as NGC 6431, magnitude 13.3, 1.6 by 0.6 arc minutes. It's a lenticular spiral, class O, 151 million light years distant. Not particularly large, probably a super dwarf-sized lenticular galaxy, 25.5 degrees above the celestial equator. Well, there wasn't much of a jump to NGC 6429. It's got a different spec. Let me give it to you. NGC 6429, a galaxy in Hercules, magnitude 13.1. Oblate, 1.8 by 0.7 arc minutes. It's a spiral with a large bar and an active nucleus, 156 million light years distant. Okay, let's watch this one form. NGC 6430, also a galaxy in Hercules. We've had 3 in a row now. Data on it. As the data pops up, I want to let you know that I'm trying to cover everything in a range of 50 NGCs. So starting at 6400, going to 6450. Hopefully there'll be 1 in 3 will be accessible, which means basically that we can get 15 to 20 studies in on a given evening. This is NGC 6430, Galaxy and Hercules, magnitude 13.8, largest 1.9 by 0.6 arc minutes, so it'll have an oblate presentation, a spiral of lowercase a and b, 136 million light years distant in the sky's middle third at 18 degrees above the celestial equator. You should be able to watch this one form on the screen. You want to pay attention because it's a planetary nebula, NGC 6439. Ooh, looks pretty messy up there. This is actually in Sagittarius, so there's going to be lots and lots of stars. It'd probably be very difficult to pick this baby out. The stars are looking better. NGC 6439, planetary nebula in Sagittarius, magnitude 13. Very tiny, 6 by 5 arc seconds, 20,600 light years distant. Central star is magnitude 18. This is probably one of the most distant planetary nebulas I've seen. Most of them are in a range of 5 to 10,000 light years maximum. 20,600, magnitude 13. This baby is spewing some highly active ionized gases to be that bright. Anyway, can't be sure what it is. I have to watch the screen develop tomorrow just to get a sense. Okay. Our next study is NGC 6440. You can watch it develop on the screen. I just made it bounce. It's a globular cluster. I believe I imaged this one before, last year when I started off imaging. And you can see the cluster right there. It's pretty intense. Yes, indeed. We have come full circle with this baby. Globular cluster Sagittarius, NGC 6440, magnitude 9.3. Pretty small, 1.7 arc minutes. It's brightest stars are magnitude 16.7, which is kind of pushing it. That's almost 7 magnitudes. That is 7 magnitudes greater. It's only a class 5 of 12 though, 26,000 light years distant, not very large, so it's very condensed, very small. It's at the distance of the M13, the Great Hercules cluster, and the Hercules cluster is about 5.8 magnitude, so this is pretty tiny, pretty condensed, in a nice stellar field. Well, here we have another globular cluster, NGC 6441 in Scorpius, magnitude 7.4, largish, 7.8 arc minutes. Brightest stars are magnitude 15.4, so these stars are 8 magnitudes fainter. It's a class 3, which means very condensed at a distance of 32,000 light years. Smallish compared to, let's say, M13 at 25,000 light years and some 19 or 20 arc minutes in size, but highly condensed. And you can see it right there. I'm not sure what that other very luminous study is on it, but I suspect the globular is this one. Not sure what that is. Probably just a bright star, like a 5th magnitude star. We are tilted, minus 37 degrees. NGC 6442 in Hercules. You can imagine what it is. Let me give you the data as it forms on the screen. pretty well centered right there, isn't it? Very nice go-to alignments tonight. NGC 6442, Galaxy and Hercules, magnitude 12.6, 1.8 by 1.6 arc minutes. It is an elliptical, which means it's bright, condensed light towards the core. Looks like a globular cluster pretty much, some 290 million light years distant. In the sky's middle third. I'll have a look at this one taking form on the screen. NGC 6444. Open cluster in Scorpius, deep south. We're getting close to getting to 6450 this evening. Everything seems to be culminating at about this point, so the synchronization's been pretty good. I started off near culmination and ending up near culmination as we proceed towards the east in the NGC catalog. NGC 6444, open cluster Scorpius, magnitude 12. It says it has a star of magnitude, no, it's 12 arc minutes in size. It has the star in it of magnitude 11. It's a 1V1 class open cluster, 1800 light years distance, and almost 35 degrees south. It's not giving a size, it's 12 arc minutes, so this is probably pretty much our cluster here. Very linear, look at that, wow. We're going to want to watch this one form. It's a planetary nebula in Sagittarius, NGC 6445. Oh yeah, pretty obviously right there, isn't it? 6445 planetary nebula, Sagittarius, magnitude 13, largish, 35 by 30 arc seconds. Its central star is magnitude 19, 4500 light years distant, minus 20 degrees down. But there is our view of an obvious planetary nebula, and I do believe I have imaged this study last summer. Okay, so I've run through all the way to 6550. The last couple were Galaxies and Hercules, however, they were both too far up at the dome of the scope. What we're looking at now is M57, showing you how good the tracking has been tonight. What I'm going to do is I am going, oops, to give you a view if I can get this thing lined up. Okay, I'm going to start off with a 2-inch view of the Ring Nebula. Give it a chance to formulate. So at 2 flood, we basically got a 2-inch telescope operating at 75x. I would expect to see the ring in this field, except for the magnification's too high for this, for anything nebulous at 75x would be pushing it into the scope. Let's go to 4. This would be like a 3-inch telescope view of the planetary nebula. M57. We go to 8, and now we're talking something like a 4-inch scope. And I'm seeing the ring there. I'm going to drop it down again, because I can just make it out at this angle. I want to see if it disappears. Yeah, it disappeared. 8, now I can see it off angle from the screen. So that's kind of a 4-inch view of 57. If we go to 16, so notice every time I increase it, basically what we're doing is adding half the aperture to it. So if this was a 2-inch, when I doubled it to 4, we went to a 3. So you take half a 2 and you add it to 2, and that makes 3. All right, then when you doubled it, when you go from 2 to 4 to 8, that doubles the aperture to 4. You take half of that and you add it to 4, 2 to 4, and you get a 6-inch. We should be starting to see a sense of a star around the limb, but not the central star. Yeah, it is. That's a 13th magnitude star near the rim of Messier 57, right about over there. 32 takes us up to about a 9-inch scope. Now you notice, look at the beautiful diffusion of nebulosity towards the core, and at this position here, you can see some diffuse nebulosity as well. So now we're starting to get some real texture in the Ring Nebula. 64. So now we're up to a 12 or 13-inch scope, and the exposure time is simply overwhelming the view. So we're going to go back to 32, and we're going to basically realize that the best view you're going to get of using real-time imaging on a 6-inch scope is at 32 flood, which corresponds to about a 9-inch aperture scope. And with that, we're going to say Carpe Noctem. And we ran from 6400 to 6450, and we probably got 20 to 22 different studies of various types. Planetaries, globulars, opens, galaxies, although there wasn't a single nebula in that series. But we'll see more of those in the future. Carpe Noctem.